So we're going to continue on with that lesson 7.3, and we're just going to talk about more on fractional or rational exponents. I'm just going to call it fractional exponents. And so today's date is the 21st. So what I want to talk about is what do you get when it isn't a 1 in the numerator and you have got a fractional exponent. So we've seen 1/2 square root. We've seen 1/4 fourth root. We've seen 1/3 cube root. What if it's got a number other than 1 there? So for example, okay. So we kind of talked about this on Friday, how we could write it down. But what I want to do is to show you a different way, okay? And the different way is the denominator tells me what of that rational exponent? Tells you the index. So we know this. Now, what we were doing on Friday is we were putting the numerator onto the guy under the radical sign called a radicand. But I'm going to show you a different way you can do it. What you can do is put it outside. So we can figure out what the cube root of 8 is, and then we can square that answer. We're actually going to get exactly the same answer, okay? Now, again, you should have memorized what cubed gives you 8. Who knows that? 2. So we know what 2 cubed is. The cube root of 2 cubed, we get out 2. But now we have to square that answer. And what's 2 squared? 4. Okay? So this is what it says algebraically. If I have a base that's raised to a fractional exponent where I have 2 different numbers and the numbers don't equal 1, okay, especially the numerator number, what we can do is rewrite this as the nth root of the base and then raise the whole thing to the mth power. This means exactly the same thing we had talked about on Friday. It means the same thing as this. These mean the same thing. It actually, I think, is easier when you can break it down into just the denominator and just a base number, and then raise it to the exponent number. This way, it's going to make it a little bit more complicated. So let's play out the question we just did, but let's do it the second way. If we did it the second way, so I'll do it in a different color, we would have the cube root of 8 squared, which would give us the cube root of 64. And now we're dealing with larger numbers. And now I've got to figure out what I can do. So we break this down. We may say 8 and 8, 4 and 2, 2 and 2, 4 and 2, 2 and 2. And we get 2 to the 6th power. So now what we would have to do is think about converting this maybe back to rational exponent. What's the numerator for that 2? The numerator. Yeah, it's what's attached to the base. And what's the denominator? What's the denominator? 3. That's the index. So we get 2 squared, which gives us the answer 4. But look at how much more work it took me to get that answer than using this idea of let's take the index root of that number and then let's raise it to the power. Okay? So let's do some examples of that, and that's what you're going to see more of on the homework tonight. Okay? All right, so let's try. Directions are just going to say simplify. And remember, simplify means you need to not have any exponents left over. You need to try to give me a numerical answer to this one. So let's do 64 to the 2/3 power. Okay, so the new strategy says, what's the root we're going to take 64 to? to the third root, so we're going to take the cube root, and then we're going to square that answer. Now, if you were just paying attention, what number cubed equals 64? Philip? 4. So we've got the cube root of 4 cubed, and then we're going to square it. So what's the cube root of 4 cubed? 4. Remember, when the index and the exponent under the radical match, then the base comes out, and now we're going to square that answer. What's 4 squared?
16.
There's your answer. Okay, let's try another one. Is that, all right. 36. Let's take it, to the 3/2 power. Okay?
Is that a 6 or a B?
36. No variables. So, what root are we taking the 36 to? Second root. So we're taking the square root, and then we're going to cube that answer. Well, we should know what the square root of 36 is. What is it? 6. And if you remember from a question you just asked me, what's 6 cubed?
It's like 3,000.
Nope.
No.
216?
No, I don't answer. I'll try to.
216.
It's 216.
Oh, smart.
Okay.
It's like 3,000.
Yeah, I don't think so. Okay. So here's where this problem becomes challenging, is that lack of memorization. Then you come into some problems. Let's do one more. 256, and we're going to raise it to the 5/4 power. So what root are we going to take the 256 to the 4th power, and then we're going to raise to the 5th power whatever that answer is. Now, 256. Now you should know that number should be familiar to you because it should be one that you've memorized. Okay? Morgan's saying, What does 256 make you think of?
7 times 8.
No. Remember, we're looking for numbers that are the same. We're looking for numbers that are the same. So this actually is a result of multiplying something by itself. So that's actually a perfect square.
11.
No. It doesn't end in a 1.
Well, 29.
No, that would be 64.
9.
Okay.
7.
Okay, see what happens when you guys don't memorize? Now we have to do it the old-fashioned way.
15.
So let's break it down. You guys are just guessing at this point, and your guesses are bad. Okay, what goes into 256?
2.
We get 1, we get 2, we get 8. How about 128?
2.
We get 6, we get 4.
2.
32. So instead of looking for something that went in 4 times, you ended up getting something that went in more than that. So we have the 4th root of 2 to the 1, 2, 3, 4, 5, 6, 7, 8 power.
She was right. She said 8.
Okay? But it wasn't, no, 8 times itself is not going to get you what you're looking for. Okay? Now you're going to take longer to get this answer. So we're going to take this radical and we're going to change it back to exponential form. 8 over 4. So what's 8 divided by 4? So we get 2 squared raised to the 5th power. What am I going to do with those exponents? I'm going to multiply them. 2 times 5 is the 10th power. Unfortunately, because it told us to simplify, we do have to come up with an answer for this one. So we're going to have to figure out what 2 times 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 2 is.
Wait, Miss Rosen?
Uh-huh.
Couldn't you also do it, or wouldn't you be able to do it like 2 squared? So, and then you solve that, so it's 4 times 5?
So you'd have to do 4 times 4 times 4 times 4 times 4. You can do it that way too. So here's where I'm going to show you up a little bit, because you should know this. 4 times 4 is?
16.
4 times 4 is?
64. 16.
16 times 16 is 256.
Times 4 is 1,020.
And we're back to where we started.
What? 16 squared.
Yeah, the fourth root of 256 would have been 4 to the 4th power.
Oh, it's a perfect square.
I mentioned that. Yes, I did. Now we still have to multiply this by 4. So I'll take my answer over here. And I get 24, I get 22, I get 10. So the answer is 1,024. So again, the faster way of having done this problem would have recognized that 256 is at least 16 squared, and knowing that 16 is 4 squared, and then you would have squared. Ooh, that's not supposed to be a 2. That's supposed to be a 5. Sorry. And this would have been 4 squared squared, which would have been the fourth root of 4 to the 4th power, which is 4 to the 5th power. Okay? So again, you should recognize your perfect squares. There is no reason that you, at this grade, cannot memorize some numbers. And the more you memorize, the less time it's going to take you to get to an answer. Okay? All right, let's do one more. And then you guys can work on homework. And be grateful, because there was something else I was going to make you do today, but I decided not to. Yeah, you would thank me once you saw what it was. Okay.
What was it?
You'll see later. So what we're going to do is take what root?
3.
Cube root of 27. And then we're going to take that answer and we're going to square it. So
3 cubed.
thank you. Finally, somebody. 27 is 3 cubed.
3 comes out. And then 3 squared is 9. The answer is 9.
The answer is 9.
We work together as a team. Let's do some homework.
Well, unfortunately, you can't work like a team on a test. So, all right, that's it.